So I still have one.
I just took them as one. So it's right, the same as.
All right, so real quick,
The same train as you would.
for this first one, that should be what your region roughly looks like. And now I'm doing dx dy, so as y, now where am I going to have to break this sucker up is right here, and that corresponds to y equal to 1. Okay, so now, so my purpose for this is to show you all the things you have to consider to get this region set up correctly and then to translate it into limits. So this one I got to do double integral, so I got to know where that point is that I have to start the second integration. So now I'm going to go, as y goes from 0 to 1, what is x doing? 0 to 3y. Plus, as y goes from 1 to 4, x is going from 0 to 4 minus y. So I noticed a few of you guys were trying to start turning the limits before you really finish the region. And that doesn't make any sense. I got to know what region I'm talking about in the first place before I can kind of redo my limits. I'm almost sort of starting over. Well, the empty starting over. This one, this says, like somebody said earlier, y equals 8, y equals negative 1, x equals 7, x equals 2. So when you sketch this, it's really just going to go from 2 to 7 on the x, from negative 1 to 8 on the y. You can't have anything below this, you can't have anything below that, so it's going to be this rectangle here. Is that cool? And the beautiful thing is these walls, what I refer to them as, they're not really functional walls. You could argue that they are because the function can be constant. Bullshit. They are number walls. And the nice thing with number walls, there's no crossing. There's no one is dependent on the other variable. That's when things get messed up. Here, I can just turn these bad boys around. So if I wanted to do dy dx, well, as x goes from 2 to 7, what does y do? It goes from this wall to that wall. Well, this wall is y equals negative 1, and that wall is freaking y equals 8. So effectively, all I had to do was turn those around. So if you're reading the book, that's Fubini's theorem. And it's like, whoa, Fubini, hopefully didn't spend a lot of time on that, because that's just making sense. There's more to this here. That was more. Sorry, Fubini just turned over a little bit and scraped some. All right, is everybody cool with that one? Okay. This guy is a little freaky. That's why I put him last. It's even a little freakier than the double one. The only reason it's freaky is you just got to really be careful to not include more than the limits allow me to. I can't go below 1. on the y. I can't go down here. But what is this function? This is equal to x, so that's really the function y equals x squared. Those are both the same function. This, of course, this means that x can't go below 0. Y can't go below 0. So it's got to be the positive part of a parabola. So I could draw the whole parabola here, but what's the only part? So the y's got to go from 1 to 4, while x goes from, it's pretty cool with what I've drawn so far. So y's got to go from 1 to 4. So it could either be this or this. But what does x have to start at? Square root of y. It's got to start at this curve. So just give yourself some arbitrary y anywhere you want to. X has got to go from this wall to 2. And where's x equal to 2? There. So I'm talking about this region right there. That little floating, it's like a big wind came over and TV went flying. Whatever. So now I want to go the other way. Now I want to let... So now I got my region completely defined. What is this point right there? 1, 1. Okay. So now I want to go dy dx. So as x goes from 1 to 2, y is going to go from this wall... Crap, I can't go straight up. From this wall to that wall. What's this wall?
1.
Y equal 1. And this wall, of course, is y equal x squared. Now, quick, go ahead and check yourself. You can make f anything you want to, so I would make f 1. If you did this integration, you do this integration, it should come out to be the same number. And it would. Okay. Hopefully you guys realize 2a, you almost don't have to, you really actually just don't have to draw the region. You would definitely have to draw it if you set it up with this and it wouldn't work. If the inside was an interval, it just wouldn't work. But in this case, wait, let me see if you guys can do this without sketching the region, but really should, but still. Which one is going to be the outer interval? Because that's the one that's going between two numbers. So as x goes from 0 to 1, y's got to go from 1 to e to the x squared. And inside I'm going to put x, because that's my function defining my outputs, my height over that floor.
Can you make an insertion? The limits?
You could. I guess you did.
No, but
Totally, of course you could. We just went over all the way you could. You'd have to sketch it out. So please, if you're asking me if I can just turn these around, obviously that should be a big time no. I mean, unless it's a really weird situation, I'm talking exceptionally weird, the outer integral should not have any function, any variable dependence. Because this integral is a definite integral, it should come out with a freaking number, right? Now, with that said, you all day long can make the outer one variable dependent if you want to have this be an integral function. So for different values of something, you would have to, why would you do that? Right. So you definitely can't just turn this around. I mean, if you wanted to flip them around, like I said, I think I tried, let's see. This is a little bit free. So as x goes from 0 to 1, y goes from 1 to e to the x squared. So at 1, that would be e. So e is about right there. So as x goes from 0 to 1, y goes from 1 to e to the x squared, right? So it goes from here's 1, here's e to the x squared. Get out of here. So as x goes from 0 to 1, y goes from 1 to e to the x squared. So this would be your region. So the first step would be to solve this for x. Right? So it'd be ln of y equals, so that would be x equal, why not plus or minus? Because I can see it's the freaking positive, right? You guys see that? Because I can see it. It's positive. I mean, so it's not impossible, but right there I'm like questioning, I don't think that's going to come out. Nice. So to integrating this, you get 0 to 1. What's the interval of x?
X, Y.
Yeah, good, because it's with respect to y. So when you plug these in, I know. I kind of did that on purpose. That question doesn't make any sense without a d something, right? You have to tell me when it's integrating, and it says dy. So it'll be x times e to the x squared minus 1. Is that cool? So let me just see. So jump to the chase here. It'll be 1/2 e to the x squared minus x, I believe, squared over 2/3. I don't know if anybody actually, right? Because you'll distribute the x. You do a u sub in the first part. Hopefully you don't really have to. If it was 2x e to the x squared, it'd be perfect. It's half of what I need, so it's half of what it would have been. Well, you can use u sub if you have to. It's fine. And the other part would just be x, which is easy. And that's from 0 to 1. So you plug a 1 in, you get e over 2 minus 1/2. You plug a 0 in, you get 1/2, so it'll be e over 2 minus 1. Because you get minus 1/2 and then another minus 1/2, yeah. How are we doing there? Is that, you guys do that one all right? You guys are starting to look a little iffy, some of you guys, but all right. Do you finish this one?
Yeah.
Most of you guys? All right. So this one I definitely want to sketch it. Because it didn't really give me enough information about where things are meeting here. So x equals y, that's nice. X equals y squared. Just to jump to the chase here, I know I'm going to want to zoom in on this because you should be able to see that that's going to meet at 0, 0, 1, 1. Now x equals y squared is y equals square root of x. And the square root of x between 0 and 1 is actually bigger than x. So this is going to be x equals y squared, or y equals square root of x, and this is going to be x equals y. So now it's totally up to you which way to integrate this. These are already sort of in terms of y, right? So if I want to leave them like this, I want the inner one to be dx and the outer one to be dy. Because what does dx do? What does the x's do? Is y goes from what to what? As y goes from 0 to 1. X starts at this one and goes to that one. That thing I just did is so freaking key. But a lot of people don't realize what I just did, it helps everything. That little dumbbell thing I just drew. Right? It's got to start at that wall, go to that wall. What's that first wall? It's the curve. What's the curve? Rad x. If you switch those around, you're going to get the opposite sign of what it's supposed to be. Right? So rad x to x. I'm sorry. Rad. I'm sorry. Dx. So x equals y squared. And this one is going to be x equal to y. And the inside is going to be what?
2xy.
2xy. Now, the other way to write it would be x going from 0 to 1 as y does what? Y goes from this wall to that wall. So y goes from x to square root of x. There it is, the square root of x. I don't know. You should be okay with the fact that those come out to be the same answer. Even though they look drastically different on the outside, they're both based on the same region. So whichever way you do it, oh, did I do this? I don't think I finished it. I think that's hard. If I do it this way, integrate dx, the inside becomes x squared y, dy, and I want to evaluate that from y squared to y. So I get integral 0 to 1 y cubed minus, you can do it, Jeff, y5. You guys kind of with me? If you didn't do it this way, you should kind of end up with a similar looking thing. Then this will be y4 over 4 minus y6 over 6 from 0 to 1. So it'll be 1/4 minus 1/6, which is 1/12. Real quick, 1/4 minus 1/6 6 minus 4 is 2 over 24, which is 112. See, so, real quick.
Whoa.
People screw up. People try to do cross multiplication in places you can't, but if you're clever, you can use it in a lot more places than you officially are allowed to. So when I have 1/4 minus 1/6, multiply by 6, multiply by 4, 6 minus 4 is 2 over multiply these 24, which reduces to 112. Yeah, you can always do that with subtraction and fraction if you want to. Or just do it whatever way you did. Did you guys, if you did it the other way, hopefully you got the same answer.
Yeah.
Just with different exponents, I would say, yeah. What about this? Oh, yes.
I was just wondering, is the other side, part 2, did you just give us information over there?
No, we're going to talk about it. We just got to talk about this first side first. You mean this side?
Yeah.
Yeah, it's more than just information. We'll go over it. So I just wanted to give you one that was just already set up for you. Just an integration problem, that's all. So what am I integrating with respect to inside here? dy. So the bottom doesn't mean shit. Integrate 6y, you get, 3y squared. From 0 to 4. Z to 4, sorry. There it is. So when I plug a 4 in, I get 48. When I plug a z in, I get 3z squared. And then you see how so first thing you always look for is it just the poor little u sub? You should be able to see the connections here. Du of this would be 48 minus 3z squared. That's exactly what that is. You can see accent. So I shouldn't even have to do the u because it's perfect. I don't have any what do you call it? Any multipliers I have to worry about. So this is just going to be 1 over u. Yeah, ln of u. So ln of 1 plus 48z minus z cubed from 0 to 4. And when you plug a 4 into this mess, 129. And when you plug a 0, when you get ln of 1, which is 0. So ln of 129. I like it. So don't try to do weird ass shit. Always try easy shit first. And then if that doesn't work, go, oh man, it's got to be some weird ass shit. Alright, real quick. Couple things before I let you out of here. So we're about to get into a section that involves double integrals with polar coordinates. So obviously the thing I want to do before we start doing that is just to make sure that everyone remembers how polar coordinates freaking work, right? So the whole idea, of course, was I could reference a point on the floor by saying move so many over, move so many out, or I could reference that same point by saying turn by this angle and move out by this much. I mean, that's really all it is. And to be honest, you get far enough in math and you start to realize there's a lot, even way more ways than that to address that. And especially if you go to 3D, we're going to talk about stuff like spherical coordinates and cylindrical coordinates that deal with 3D, different ways to identify a point in space. Because all the different ways to identify a point in space come with different mathematics behind it. So a really difficult integral in XYZ might be really easy in cylindrical or spherical, especially if it's a spherical function or if it's a cylindrical function. Amazingly enough, it should work really well in those other systems. I get the same stupid answer. I don't care how I identify a point in 3 space. I'm going to get the same. It's the same thing if I identify it using XYZ or if I identify it using turn, move up, and go over. I mean, it's going to be the same points. So, all right, that's in our future. So, hopefully this looks familiar. Oops, what did I do?
I'm good, thank you.
Yes.
For the second part, can you just give us information or
What second part? What do you mean?
over there, number 2, A?
No, what do you mean give you information? I understand.
I mean,
Like, here's the idea. Everybody's cool with the conversions. Please tell me that's true. Because that's basically the definition of cosine in a way, right? It's x over r. So x equals r cosine, y equals r sine. R squared is, you know that. And tangent theta is y over x. So I can do the arctangent to figure out what theta would be. So that's how to convert from an xy point to an r theta point, or vice versa. All right. So, since John brought it up, if I saw r cosine theta sitting somewhere, what could I replace it with in rectangular? I could replace it with x. I love it. Right? Self-control didn't help me out. We're shit there. X likes cosine. There you go. So what's missing here then? This is where people do all kinds of weird shit. If only there was a what here? If only there was an r there, well, it's a freaking equation. What do I do to make an r show up? Multiply both sides by r. Right? So then you get, if you do that, you get what? R squared equals 5 r sine theta. What's r squared? X squared plus y squared was r sine theta. Y. Now, if I really wanted to push you, and you're like, well, you've shown that you obviously, that's the equation of what?
Circle.
It's a circle for sure. Where's the center?
okay.
Radius
You will-
that means radius square.
Are all the y pieces together? So it's not in the right form to tell anything. So you'd have to subtract the 5y and then do what? Complete the square. I love it. You guys remember that? Still, this paper is sitting here. So it'd be x squared plus y squared minus 5y equals 0. Half of 5 is 5 halves, squared is 25 fourths.
So it's supposed to be like an ellipse.
No, I know it won't be an ellipse because the x squared and y squared have the same coefficients. It's definitely going to be a circle. It's just a question of where has it moved to.
Yeah.
Do you know where the circle went? So right here, is everybody, I know I did this a little quickly, but remember the 2 steps for complete square? You cut this sucker in half. That's going to be how it factors, so there's no thought required. Half of 5, negative 5 is negative 5 halves. That's how it factors. Square it, that's what it needs to factor like that. So what's the radius of this circle? 5 over 2, and what's the center? 0, 5 halves. Cool. Great. There's a reason for that, to learn that. One of my favorites is this next dude. I know we're just skipping number 1, but I don't care. How would you convert this equation? It's currently in polar form, obviously. I'm sorry. Now, I'm not picking on you. But I want to make a real big point of this. You don't multiply by tangent, right? TAN by itself doesn't mean shit. You take the tangent of both sides. Right? I'm sorry you had to say that, so I had to. I'm not coming down on you. There's people that would have said it the same way. Why is that so important? Because it's that little thing that makes sure that you're looking at things correctly, so you don't do weird shit like divide by tan. Tangent theta equals tangent pi over 6. What is tangent of pi over 6? So it's either square root of 3 over 3, or it's the square root of 3.
Well, it's sine over cosine.
Yeah, so it goes like sine. It's big where sine is big. Pi over 6 is 30. 30 is close to x. Cosine likes x. Cosine's big, sine's small.
Yeah.
Yeah.
So what's tangent theta? So it's y, and then multiply by x. Notice how the tangent of the angle is the slope. Tangent, line, slope. Pooh. All right, right? You guys see that? Tangent of the angle is the slope of the line that goes through that point. I love it. They didn't point that out to you when you first learned this shit, then you missed out until now. Sorry. And then, what about this guy? This guy, people get all kinds of weird shit. Does R secant mean anything? R secant. Is it any part of it? No, it's nothing. But yeah, it's so secant is 1 over cosine. That's related to something. And then I get people that multiply, divide both sides by r, which is fine, but couldn't you just multiply it up? Yeah. And our cosine theta is x. And that would be a vertical line, so r equals some number times secant would come out to be a vertical line. Really kind of nifty. What time is it? All right, let's we'll do this. We'll finish this out next time. But you should try to do some of this on your own, especially down here. Oh, you know the graphing is going to be a piece of this stuff that we're going to do.